So welcome to Chapter 7, Connecting to as well as Setting up a Network. So our objectives this chapter are to learn about TCP/IP protocols, the standards for both communication and numbering, both IPv4 and IPv6 in general. No subnetting, just focusing on the addressing in general. We're also going to talk about how to connect a computer to a network and troubleshooting, as well as how to secure a multifunctional router. So let's make sure that we understand what TCP/IP and Windows Network really means. So to understand TCP/IP, we have to talk about a few things first. And normally it's this client-server type application. And essentially there are two devices involved. Normally also two applications as well. And communication occurs normally at three specific levels. And this is dependent on one computer addressing a resource from the other. So for example, we have one computer with a web browser. It goes to google.com. It goes through the internet to a web server, which then has a application on there, normally a web server, that will host or serve up the resource google.com. And that's returned to the individual in form of a web page. So when the two devices communicate, they must use the same protocol, language or standard. Almost all networks today use what's called TCP/IP or Transmission Control Protocol Internet Protocol. The reason this is important is because in the 90s and earlier, we had multiple protocols, IPX, AppleTalk, things like that. So if you had one device, you could only communicate with other devices that use the same protocol. Because again, this is a language or a standard. And this became very cumbersome. So we adopted the TCP/IP standard protocol. And that means almost everything that connects to the internet, everything, not almost everything, but everything that connects to the internet communicates over TCP/IP. Because that's the protocol. And portions of the way TCP/IP functions is it controls how data is addressed and the way that data is segmented. And what I mean by segmented is it controls the way that the data is broken up and into small manageable chunks. And those manageable chunks are normally stuck in an envelope or a data packet that we normally refer to as a packet. And then it's addressed and then sent out on the internet or on the network. A packet normally contains the data and the information that identifies the type of data, the source and destination of where that data is going. So in general, the first level is defined as the hardware level and the root level of communication. So normally this deals with wireless or wired, so it's going to be more of the physical media. And in this general sense, we're also going to include MAC addresses or physical addresses for our communication. Now, a MAC address is also known as a Media Access Control address, and it's a unique 48-bit number, normally displayed in hexadecimal number, which is hard-coded per individual network interface card or NIC card, and it's coded by the manufacturer. Sometimes this is a hardware address, physical address, the adapter address, or Ethernet address, but it is really all just a clever way of defining or stating a MAC address and the communication protocol used. And so this is just one level. So here is our general diagram. At the first layer, bottom layer, is going to be our MAC address or our standard communication called Ethernet. And we're going to move that up to our operating system, and that's going to be our TCP/IP. And there we're going to talk about our addressing. And then the very top is the actual application. Now, that area we're going to talk about port addressing. So, like I said, level 2 is our operating system level. And this is the level that manages communication between one node and another. And this also deals with our IP addressing, or our logical addressing scheme. Normally, to communicate on a network, you have to be able to address it. And that's where our IPs come into play. Every device on the internet or on a network has a unique address. So, what is an IP address? Well, there are two types, IPv4 and IPv6. IPv4 consists of a 32-bit address. 2 to the power of 32 is roughly 4 billion addresses. So that means with a 32-bit address, we can have about 4 billion devices on the internet. And while that may be realistic right now, it may not be. Because we have a lot of devices that are connecting to the internet now, so we may be running out of addresses. And in many parts of the world, they've already ran out of addresses. So that helped to develop IPv6, and that is a 128-bit address. So 2 to the power of 128 is roughly 340 undecillion. So how large is a undecillion? An example of an undecillion could be every grain of sand on every beach on the planet is about 3 undecillion. So 2 to the power of 128, again, is the amount of IPv6 addresses we have available, and that's 340 undecillion. Next, level 3 is our application level. And this is what controls the client communication with applications. And they do that via a port number. And a port number in general is a uniquely identifiable computer application number. So, we could also think of it as a socket. So if we have an IP address, we could do a colon and follow it by our port number. For example, if we want to look at email, email uses port 25. If we want to look at web traffic, we could look at port 80 or port 443, because those are the ports that define web traffic. So again, on the network, we can actually attach port numbers to our packets so that we can better filter traffic or better direct traffic based off of those port numbers. So normally the question becomes, how do we get addresses? How do they get assigned? Remember that a MAC address is embedded or hard-coded in the actual adapter, while IP addresses are logical, so that means they can be assigned different ways. Normally there's two standard ways: a static IP address, which is manually and permanently assigned to a computer, or dynamic. And dynamic is assigned by a service, normally a server, each time the device connects to a network. And normally that service is used to control DHCP, or Dynamic Host Configuration Protocol. And that seeks to control the handing out of addresses to those that need addresses. So again, IP addresses, 32 or 128-bit. IPv4 is 32-bit, IPv6 is 128-bit. And who keeps track of all of this? IANA, the Internet Assigned Number Authority, is responsible for the keeping track of assigned IP addresses for the Internet. So now that we have a general idea of our address makeup, let's look at kind of how they're done. So IP addresses are again 32-bit long, and they're made up of 4 groups of 8 bits, binary. So 8 bits, if they're all zeros, or if they're all ones, or any range of combination in between. From 0, if they're all ones, it'll go up to 255. So the largest IP address you can get is 255 dot something, because 255 is all 8 bits in a group, all ones. And again, any combination between zeros and ones can be represented. So again, that can be any number ranging between 0 and 255. Also, each group of 8 is called an octet. And again, we've already said 2 to the power of 32 is roughly 4 billion possible addresses. So we talked about addresses that can get on the internet. And those addresses are specific types of addresses. But before we get into that, how can we organize or classify our addresses? We break them into 3 distinct groups. There's really a class D and E, that's outside the scope of this course. So a class A network is a network that starts with the number 1 or starts with 126 or numbers in between. That will be classified as a class A network. There are 126 possible networks, and each of those 126 possible networks consists of about 16 million addresses per network. Class B starts with 128.0 and ends with or goes through 191.255. And so there's any combinations between 128.0 and 191.255. That means there is roughly 16 million networks. And each of those 16,000 networks, I said 16 million, I apologize. I meant 16,000. Each of those 16,000 networks each consist of 65,000 hosts or addresses per network. Lastly is a class C, and that starts with 192.0.0, and that goes through 223.255.255. And again, there's 2 million different networks, and each network consists of 254 total addresses. This is called class full addresses. And again, this is just an intro to our addressing. This is by no means an in-depth look at our IPv4 addresses. So, we have a class A address. The first octet identifies the network, and the last identifies what addresses we can assign. Versus class B, the first 2 octets are locked in, and the last 2 define what we can hand out to our hosts. Class 3, or class C, the first 3 octets are identified by the network, and that means the last octet is what we use to identify our hosts or to assign our hosts. So again, the network portion is locked in. The host portion is what we get to assign to our devices. Now there are specialized addresses like 0000, and that's an unassigned IP address. There's also straight 255s, those are broadcast addresses, but there's also that 127.0.0.1, and that's a loopback address. And essentially that's an address that says, hey, look back at me. So, subnetting or grouping of IPv4 addresses. We can take large networks and divide them the ways that we need to divide them. For example, a class A network of 69,000. We already said that 69, that means there will be 16 million hosts. But we can divide this into different ranges or different groups. That way, we have different groups. We don't have to have one large network of 16 million addresses. So the subnet mask identifies which part of an IP address belongs to the network and which belongs to the host. That way we know kind of where to send it. And here's an example. A subnet mask will lock in which numbers we get to play with. If any group is all ones, that group is locked in. So with the class A, the first group is locked in. They're all ones. That means that octet is locked in. We don't get to touch that. We can play with the remainder. For class B, the first two groups are locked in. We don't get to change those. We can play with the last two. And class C, lastly, controls the first three octets. They're locked in. We don't get to change those. We only get to play with the last octet. Again, this is classful networking or classful addressing. So this is not true in all cases because we have the thing called class lists, and class list no longer is tied to class A, B, or C. But again, that's outside the scope of this. So a network could be divided into different groups. Those groups are called subnets. And so we can actually divide them by a subnet mask. So if we took that class A address, and normally it would have a 255.0.0.0 address because we only want to be able to lock in at 69. We could give it a subnet mask of 255.255. That means instead of just locking in the first one, we could lock in the first two. That gives us different groups that we could play with. So with all of this addressing information, are all IP addresses allowed on the internet? And actually, no, they're not. Only public IP addresses are available on the internet. We have certain addresses that are set aside, known as private IP addresses. And there's a technique called NAT, or Network Address Translation, that allows us to mask or map a private IP address or several private IP addresses to a public IP address. At home, if you have a router and you have multiple computers, you probably have several private addresses. And it goes to your cable, your ISP, and your ISP gives you one public address. So all devices on your home network have a private address. They're mapped to your ISP's public address. So what are the private addresses? The private addresses are any number that starts with 10, so any combination of 10 is a private address, or an address that starts with 172.16.0.0 through 172.31.255.255, or any combination in between those numbers. Lastly, 192.168.0.0 through 192.168.255.255, and again, any combination in between. So that is our wrap up for IPv4 addresses. Now let's go ahead and talk about IPv6 addresses. Here they're broken up in 8 blocks of hexadecimals that are separated by colons. Each block is consistent of 4 hexadecimal numbers. Leading zeros in a 4-character number can be eliminated. So if we have the IP address 2010:000:B80:000:D3:9C5A:CC, what you do is they removed all of the leading zeros because if you have B80, you know you're missing one number. If you have D3, you know you have missing 2 preceding zeros. You only are allowed to do it at the very beginning, not at the end. Because if you removed the end zeros also, you wouldn't know if it was B800 or 00B8 or any other combination. So you're only allowed to remove the first 0. Also, you are allowed to use one double colon, and a double colon represents a string of continual zeros. Here we have two things of continual zeros. You cannot do double colons in two places. You're only allowed to do them once, and normally you do them with the most zeros. So we're going to represent all of these with double colons. So terms to know for IPv6. A link local, or a local link, and that is a local area network or a LAN, or a WAN boundary by a router. That's going to be a local network. Interface. Interface is the node's attachment to a link, and that link could be a logical link or a physical link. The logical attachment is used for tunneling. Next, an interface ID. Typically, the last 64 bits or 4 blocks of an IP address is used to identify the interface. Next is this thing called neighbors, and these are 2 or more nodes on the same link. We can define as neighbors. 3 tunneling protocols for IPv6 packets to go over an IPv4 network, because these are different standards. Is this intra-site automatic tunneling address protocol. There is a Trito, which is an address intended to be used by this protocol, which is the same 32 prefix, which is 2001, or there's also this 6 to 4, which is an older protocol, which is replaced by Torpedo or ISATAP. So these are just a few of the different types of tunneling protocols. This is not overly important because this is out of date and there are a lot more current ones that are referred. So types of addresses used for IPv6 are unicast, multicast, anycast. A unicast is a one-to-one, a multicast is a one-to-many, and an anycast, normally used by routers, identify multiple destinations and packets are delivered to the closest destination. As opposed to the IPv4 address types, which is unicast, multicast, and broadcast, which is again one-to-one, one-to-many, and one-to-all. There are several types of unicast addresses for IPv6. There is a global unicast address, which is a global address, and this can be routed on the internet. And they normally begin with 2000/3. That indicates the first 3 bits are fixed and always 001. So that means our first number could be range of 2000. Next we have a link local unicast address, and this is a link local or a local address which can be used for communicating with nodes in the same link. Normally they begin with FE80. If it begins with FE80 followed by enough zeros to make 64 bits. That's common what happens with link local addresses. Lastly, there's a unique local address, which identifies a specific site within a large organization. And the prefix for this normally is FC00/7 or FD00/8. So again, the first 3 bits for a global address, then we have a global routing prefix, subnet ID, and interface ID. If it's a link local, it will more than likely begin with FE80. And the first 64 bits will be remaining 0. The unique local address, the first 8 bits will either be FC or FD. Then the next 40 bits will be a global ID, then subnet ID, and interface ID. So how can we verify our IP settings? We can do what's called an IP configuration command at the command prompt. So ipconfig should yield us something that looks like this. And we may have multiple links. And so we may have an IPv6 address. We may have an IPv4 address, a subnet mask, and a gateway. So let's try that one more time. IPv6, address, subnet, default gateway. We may have other things like a domain. We may also have things that could be a DNS setting or DHCP server settings or additional information. And we could have multiple network adapters. Like this is our wireless card, and this is our wired adapter. This one is our wireless. We could have multiple depending on how many network interface cards we have per PC. So character-based names identify computers and networks. So we could have character-based names which will substitute for an IP address locally. And that will be things like a host name or a workgroup name or domain name or a fully qualified domain name, which will identify the computer and the network in which it belongs to. Normally uses a name resolution like DNS, domain name services, so that we can find the IP address that will match the fully qualified domain name. And that will be something like computername.domain name. So layers for our TCP/IP protocol is normally broken down into 7 different layers for our OSI. And OSI is just one model of many. And that starts with layer 1, physical, layer 2, data link, layer 3, network, layer 4, transport, and layers 5 through 7 is session, presentation, and application. And each layer has specific items tied to it, like the bottom 2 deal mainly with the hardware. The network deals with the addressing, the IP portion. The layer 4, the transport, deals with end-to-end communication. Then the remaining is going to be normally what's installed by an operating system, and this is going to be application, presentation, and session layer protocols. What's going to be happening going back and forth. So we have a few different types of protocols, TCP and UDP. And TCP is connectionless oriented, meaning, or connection oriented, which is different from connectionless. Connection oriented is guaranteed. It will actually send back an acknowledgement or an ACK to verify that you got it. And that differs from UDP, or User Datagram Protocol, as UDP is connectionless, and that's best effort. I send it out, and I don't care if you get it. Where TCP is guaranteed delivery. We have to know a few protocols that are used by applications for our exam. Things like HTTP, which uses port 80, and that is for Hypertext Transfer Protocol. For HTTPS, or Secured HTTP, or HTTP over SSL, that uses port 443. SMTP, Simple Mail Transfer Protocol, we use this to send email, and that is port 25. Next we have POP, POP uses port 110. IMAP uses a different port. Those are used for delivering email messages. Telnet uses port, I believe, 23. I don't remember. I can't remember it off the top of my head. But I mean, it uses a specific port, and it's used for remotely controlling a computer or device. We also have LDAP, SMB, FTP. FTP uses port 20 and 21, and it is used to transfer files between two devices. SSH is a secure way to control, like Telnet, but a better secure way. FTP has a secured portion that's called SFTP, or Secure FTP. We also have things like SNMP, or Simple Network Management Protocol, which could be used for basic management of network devices. And lastly, we have Remote Desktop Protocol, or RDP. And that uses port 3389, and that allows for remote control of a desktop. So how do we connect to a network? We talked about our addresses, we talked about ports, we talked about applications, and that's the bare minimum for understanding our addressing and application and how they communicate. But how do we take that information to connecting to a network? So we're going to talk also how to connect to a network using both wired or Ethernet, wireless, and I'm going to slightly talk about dial-up and VPN connections. So to connect to a wired network, it's pretty simple. First, verify you have a network adapter installed on your computer. Then connect a network cable, which should have an RJ45 connector from your device to your router or switch. Should be a switch. And that device should give your PC a dynamic IP address, because earlier when we said DHCP is a server or service, our home routers have DHCP running on them. And as long as you hooked up the correct cable between your PC and your home router, which is actually a router and a switch built in, but that's another conversation, you should be able to get internet access, assuming that from your ISP, let's say you have a broadband modem, and that's connected to the WAN part or the internet port of your router. So connecting to a wired network, troubleshooting. First, make sure that you have the appropriate network adapter or the NIC driver or the NIC card. Make sure that you have drivers for that NIC card. Make sure there's no red X's. Also, make sure you get an IP address. Make sure the cable is plugged in. That's always a common one. You should be able to see if you have a healthy network connection by going to the Networking and Sharing Center in Control Panel. And here you'll be able to see if you're connected, wired or wirelessly. If you're not, you may have a red X up here. From this side, you can manage your wireless settings, manage individual adapter settings, manage share options, and configure your firewall. So that's a lot of good information for this screen. So if you want to change TCP/IP settings, you should be able to click on the Change Adapter Settings. You would go to the appropriate properties, and then you'd select the appropriate address properties. If you want to change IPv4 addressing, like that's normally what happens, you'll click on the TCP/IPv4 properties. By default, things are dynamic. You could change them by clicking on use the following address information, and then you manually enter it. That becomes a static address at that point. So you would change the IP address, the subnet mask, the gateway. Also, you could change it to DNS if you wanted to. So normally once you've done all of that, you may want to disable and re-enable your NIC to bring up all the settings. How you do that is you right click on your physical adapter and you should be able to click on disable. You double click on it to re-enable it. So how do we connect to a wireless network? Let's assume it's an unsecured public hotspot or even a secured private hotspot. It really doesn't matter. First, make sure you have a wireless adapter. Make sure the wireless adapter is working and you have current drivers. If it's a laptop, make sure the wireless is turned on. That's common. A yellow star in the network icon indicates there should be a hotspot available. If you connect to a hotspot, you may be asked to enter a key or password. Click OK. If the network is unsecured, verify that Windows has configured as a public network. So when you first connect to a new wireless network, it's going to ask what type of network, home, work, or public. By default, they put most things in the public network. That just turns off shares. That way, if you're at Starbucks, you don't have shares enabled. And again, test the connection to make sure you have connectivity. So things that you may need for your wireless network. If you're setting up an access point yourself, you're going to need a security key. You're going to want a SSID name. The broadcasting is subjective. Most people say turn off broadcasting, but it doesn't really matter anymore. Our name, or SID, also stands for Service Set Identifier, name of the network. You can also turn on things like MAC filtering, so you can set it to only the MAC addresses that you know can connect to your network. That's more time consuming, but it's there. If you have a cellular card, you could connect using a SIM card. The SIM card is built in or an add-on card that your carrier gives you because they're not built into the phone. The phone has a built-in spot for your SIM card, but that allows you to connect to your carrier. You can tether your laptop to your cell phone so that the cell phone will act as your internet provider. So how to connect to a cellular network? Normally by turning it on for the functionality of your phone. So lastly, dial-up, barebone installation. Normally you set up a new connection in networking sharing and you enter the appropriate ISP informations and you click connect. To verify, you'd click on connect to a network, you'd enter all the appropriate dial-up connection information, and you'd dial the connection. While dial-up connections aren't very common anymore, it's always good to kind of know the steps. Troubleshooting, normally verifying the phone cord that's plugged in on both ends, and that you have all your ISP information correct. Next is VPNs. VPN is a private virtual network, and it is used by a remote employee, typically, to securely connect to a resource through the internet or through a different network. There are different types of VPNs, and a big part of this is recognizing you have to have a start and destination so that you have a secured link in between. General steps to setting up a VPN is you can click in the Network and Sharing Center, set up a new connection or network, and then you would connect to a workplace. You would then choose the Use My Internet Connection VPN, enter the appropriate IP address to the other end of the VPN. You should have credentials and click connect. Most of this you're going to be getting information from your ISP or organization that set up the other end of the VPN so that you can connect to the VPN. Setting up a multifunctional router for a small office home office. Normally, it's a pretty straightforward process, but we have to talk about how to set it up and how to secure wireless. So function 1, it acts as a router, and it sits between the ISP and our home network. It also acts as a switch, also acts as a DHCP server, and also acts as a wireless access point. So these home routers act as multiple devices. They could also act as a firewall and as an FTP server. So it's not just a few things, they have lots of functionality. So how do we install and configure it? First, on one of the computers on the network, I take that back. Before you even do that, you need to take the router out of the box, follow the instructions on the router, and plug it in as it outlines. Normally, on the internet port, you're going to plug into your cable modem. On the ports to computer, you're going to plug one of the computers in. Normally, the instruction guide will tell you how to get an address and how to connect to the router. So step 1, after you've done the router unboxing and basic setup, you're going to follow the manual to access the router. Once you're in the router, you're going to do things like set up your ISP connection. Normally it's DHCP, but you want to make sure of that. Normally you're going to move to the wireless portion. You're going to do things like setting up an SSID and a password and securing it. Also, might also do things such as changing the password to your router and then testing the connection between the computer and the internet. Also from a wireless device to the internet. That way we can make sure we have all the settings set up correctly. So if we're looking at updating software on the router, things like its firmware, we could open our browser, navigate to the address of our router, enter the appropriate credentials to log into it, and you're going to go to some type of administration or update page that will allow you to update firmware. And at the very end, you're going to save your settings. So recap. For basic configuration, you want to change the router password, you want to set up a SID, set up a password, configure the DHCP server settings on your router, verify the address information provided by your ISP, and configure other items as required. Other items to talk about is port filtering, port forwarding, and port triggering and DMZ. So port filtering is used to open or close ports. So if you want to block ports, we can filter based off of ports. If you want to be able to play a game and have ports forwarded specifically to your computer through the router, we could do that through port forwarding. And that basically means if something comes on this port, send it directly to this computer. That's what port forwarding in a nutshell does. Port triggering opens a port when a PC on the network internal initiates communication through that port. So you can block all ports except for those that are triggered. Meaning, if someone from the inside requests something, that port will be open for that device. Lastly, the DMZ or demilitarized zone, and this is going to be normally in between the router and your ISP, and that's allowed for outside access, but less secure. So tips for using port forwarding. Normally you want to set it so that a specific port is going to be going to a specific computer on your network. Setting up your wireless, you may have to choose wireless channels or wireless standard types. So we have A, B, G, N, AC. We have different types of wireless standards. You want to choose the appropriate wireless standard that fits your needs. For example, if you have a bunch of G and N devices, you don't want to set it to N only, because all your devices that are G no longer can communicate. Channels that they're on. Normally for the 2.4 gigahertz range, you want to use channels 1, 6, or 11. Always set wireless channels to 1, 6, or 11. Most devices nowadays are going to be between B, G, and N, but realistically it's more G and N because we have a new wireless standard called AC. N is no longer the newest standard. But N does bring up some unique challenges. It brings up the 5 gigahertz range and the 2.4 gigahertz range. So normally you have to select channels in setting up your wireless. 2.4 gigahertz, we're going to use channels 1, 6, or 11. But now we also have options in the 5 gigahertz range. So you want to have to see what channels are available for 5 gigahertz. Also, you may have to deal with things like wireless encryption. Things like, is it going to be a WEP key, or is it going to be a WPA key, or WPA2 key? And this allows you to secure your wireless with a password. WPE and WPA are pretty weak encryption and can be broken into very easily. WPA2 is a newer standard and is a little harder to break into. Not impossible, but a little harder. Other forms of securing your wireless could be, again, disabling your SID broadcast or MAC filtering. And in a nutshell, that is this chapter. Thank you.